Okay, this video is all about formulas for ionic compounds. So we know what an ionic compound is. Now it has to be a metal and a non-metal. We talked about their properties with the higher melting points and the higher boiling points, and the crystal lattice and lattice energy. So now we're going to look at how these formulas are written. We drew the dot diagrams earlier, so that was an introduction to writing formulas. But now we're going to look at how to write these without having to do those dot diagrams every single time. And so we start off here with what is called a formula unit. Okay, formula units are just the chemical formula for an ionic compound. It's kind of like molecules or atoms when we start talking about other types of bonds. We really should say that each ionic compound is so many formula units instead of so many molecules or so many atoms. We talk about an entire compound like NaCl, that should be 3 moles of NaCl formula units. Okay, NaCl is not really called a molecule, it's actually a formula unit. So it's just a name. Okay, these are, though, the simplest ratio of ions. Okay, and there'll always be a repeating pattern. We start talking about then different types of these ions. Okay, we have monatomic ions. Mono meaning one. So these are one atom ions. They have a charge according to the periodic table. Alright, so if we then look at monatomic ions, their charge is according to where they are on the periodic table. Okay, if lithium and hydrogen, should be over here as well, are in the first group here, they will lose 1 electron to look like their noble gas. So these are all a 1 plus. If we look at then the second group, which need to lose 2 to look like a noble gas, these are all a 2 plus. Then the transition metals each have their own charge, usually a 1 plus to a 2 plus, but not always. Okay. When we go to the group with boron, boron's group needs to lose 3, so everything in here is usually a 3 plus. And then we go to carbon's group. Well, carbon's group actually needs to gain 4 to go one direction, or lose 4 to go the other direction. So those actually don't lose or gain. They're involved in a different type of bonding, and this group here really doesn't have a charge. Okay. Nitrogen's group needs to gain 3 to look like the noble gas. So these are a 3 minus. Oxygen then needs to lose 2, Oxygen then needs to gain 2, so it's a 2 minus in this group. And then fluorine needs to only gain 1, so the halogens here are 1 minus. So the charge of any single or monatomic ion is just based on where it is in the periodic table, which group. Just remember, like I mentioned, that the transition metals can be different charges. So when we look at this table, okay, that you have there on the right side of your notes, these are all transition metals. And what we'll see here is that chromium has a 2 plus and a 3 plus. Vanadium can be 2 plus or 3 plus. Copper can be 1 or 2. Okay. Tin can be 2 or 4. Lead can be 2 or 4. Those are actually transition metals down there in the bottom groups. So they can kind of fluctuate. So they have to tell you which transition metal charge that particular metal has. Okay. Alright, so let's look at then what are called oxidation numbers. And that's kind of just a fancy term for charge. Okay. These are the charges of the monatomic ions. And they stand for the number of electrons transferred to make the ion. How many did they lose? How many did they gain? If I want to write a formula for a binary ionic compound, the first thing you do is you write the cation, which, remember, that's the metal. Then you write the anion, which would be the non-metal. The number of ions is the subscript. And your total charge should be 0. Whenever one loses, the other gains. You always write the charge for the cation and then the charge for the anion, and you add more cation or anion to balance the charges. And when you actually write the formula when you're done, you do not put the charges in. It's kind of like when you're learning it right away, the first step you do is write the charges in, but once you learn what you're doing, you don't have to do that anymore. So let's look at some examples. Okay, determine the formula for the ionic compound formed from sodium and sulfur. Okay, well, sodium is in the first group, so it is an Na1+. You lost one electron. Sulfur is in the sixth group there. It needs to gain 2 to look like a noble gas, so it's a 2-. So I need 2 of these pluses to equal out that minus. Well, instead of putting something like that, okay, we write Na2S. You have 2 sodiums and 1 sulfur. Now let's look at the one for aluminum and oxygen. Okay, aluminum is in the group that needs to lose 3 to look like a noble gas, so it's a 3+. Oxygen is in the same group as sulfur, or it wants to gain 2. So now we've kind of got to make these equal. Well, I can't just add 1 oxygen, because now we're at 4- and 3+. So I add another aluminum. Well, now I'm at 6+ and 2-. So I add another oxygen, and now I'm 2- and 3+ and 6+. So it's Al2O3. The number of ions you use is just the subscript. Okay, let's try the last one. Palladium 2 phosphorus. Palladium is a transition metal. So what they do is they put the charge in Roman numerals. Okay, so I know it's Pd2+. They're telling you what it is. And phosphorus is in that group that wants to gain 3. It's a 3-. It's kind of just backwards of the previous problem. So I add 1 more. I'm at 4. Add another. I'm at 6- and 4+. Another palladium at 2+. I'm good then. Pd3, P2. All right, those were monatomic ions. Now we're going to look at how to write formulas for what are called polyatomic ions. Well, a polyatomic ion, poly meaning more than one. Okay, so these are ions that are made up of more than one atom. But they act as an individual group with a single charge. The subscripts for these never change. Part of a group. If you need more than one, okay, in a formula, you need to use parentheses. And then a subscript. And in order to know these names for these polyatomic ions, you need to look at the back of your periodic table. And you will see this chart over here to the right. These are all the common polyatomic ions. There are other ones. I just didn't put them on the back of this sheet, okay? But this is pretty much all of them, the ones you're going to come across, okay? And so if you see a name that you're not used to, okay, something like nitrate or carbonate, look on the back of your periodic table and it will tell you what it is and what charge it has. So let's try some of these. Okay, sodium and nitrate. Notice it doesn't say nitrogen, it says nitrate. So it's not just N. We look on the back of our periodic table, and you should see for nitrate, it's NO3, 1-. So you see there it's NaNO3, okay, because each one is a 1+ and a 1-. They balance out nicely. If you look at then calcium, okay, calcium is Ca. It's in group 2. It needs to lose 2 electrons, so it's a 2+. I don't know chlorate. It's not chlorine. Okay, so I flip over my periodic table, look on the back there, and I should see ClO3 with a minus. So these charges do not equal out. I need one more of these ClO3s. So what I do, okay, I put Ca, and I cannot do this because that would not make any sense. All right, so what we do is we put this in parentheses, meaning I need 2 of those groups. All right, let's try the next one. Aluminum and carbonate. Aluminum is in the group that is going to lose 3, so it's Al3+. We find carbonate, not just carbon. So I flip over my periodic table and find it. It's CO3, 2-. Okay, now with the same problem I had with aluminum and oxygen earlier. I need more of each. Okay, I'm going to end up needing 2 of these and 3 of those. So I go Al2, parentheses, CO3, 3. You need to have the parentheses. Okay, strontium and hydroxide. Strontium's in the second group. It's an Sr2+. Hydroxide, flip over the periodic table. I'll tell you it's OH-. So I need 2 of these OH-. You will often want to do that. Well, that's not right. I need 2 H's and 2 O's. So you have to put it in parentheses. This one's easy to forget because there's no number there, okay? But it needs to be there. Let's try potassium and permanganate. Potassium's in group 1. It's K. It's a 1+. I don't know permanganate, so I look at the back of my periodic table. It tells me that it's MnO4-. So they're equal. I just go K, MnO4. Last one. Copper 3. Remember, that means that I go Cu 3+. It tells me the charge. And bromine, well, that's normal. So I go Br-, Cu, Br, 3. Because I need 3 bromines to equal out that 3+. And those are the formulas for ionic compounds.